All right, hello algebra students. Welcome to day 3 of Miss K not being here. Hopefully you are being fantastic for the sub. And I know you're probably not wanting to do another video with notes after yesterday's 20-minute long video. But do keep in mind that the videos are nice because you can slow down if you need, or you can speed up if you're understanding the material. So if I'm doing 3 or 4 examples and you got it after 2, then don't go through the last 3 examples. On the second part of that, though, if you are having trouble, rewatch the videos. And if that's still causing you issues, then please make sure you're talking to other students in the class, if allowed by the substitute, and checking your book for further examples and explanations. Okay, so today's lesson 4.6 is over direct variation and standard form. Direct variation we covered last year in 7th grade, and standard form we've already started covering this year, so this should be a much faster notes-taking session. Okay, so direct variation, if you remember from last year, is another way of saying proportional, which means that x and y increase at the same amount. And in this situation, the amount that it increases by in this situation is a. Why they call it a when there's no y-intercept at the end, I don't know. Last year it was k, this year it's a, and slope is m. But anyway, so direct variation is going to be shown in a graph when the graph passes through the origin. So you can see all 3 of these graphs down here are passing through our origin, which indicates to us there is a proportional relationship, or the fact that there is direct variation. So the way that this graph is differing from our slope-intercept form, this equation is differing from slope-intercept form, is that it doesn't look like it has a y-intercept. However, it does. It's just the fact that our y-intercept is 0, so it's not required to be written in the equation. So if our y-intercept is 0, that means our graph crosses at the origin or 0. And then if x increases by a, then obviously y is also going to increase by a, since nothing else is happening to my input. As I already said, direct variation talks about proportional relationships. And we call the slope the constant of variation, or also the constant of proportionality, which we talked about last year, which we called k. So all of these down here are examples of proportional relationships because they are straight lines and they are going through the origin. And x and y are increasing at the same rate. So when looking at a table, we can determine if we are seeing direct variation without having to graph it. You always could graph it, but we can actually look at our table instead. So if we know that proportional or direct variation is shown by graphs going through 0, 0, then we can actually just count backwards until our x is at 0. And we can do the same thing with our y values. So here my y's are counting up by 99 cents. So this would be $1.98. And then 1 would be 99 cents. And then I would be left at 0 for x. This point here indicates that we are dealing with a proportional relationship. So yes, it is proportional. The equation would be y equals my slope x, and then I don't have to add anything because it would be plus 0. So here my slope is what I'm increasing by, which would be 0.99, which is what my y's are increasing by, over my x's are increasing by 1. Now, obviously, you wouldn't have to put it over 1, but for slope's sake, I went ahead and put it as a fraction. Describing the graph, it is going to go through 0, 0. And it's going to be a straight line because these are all increasing at a constant rate. So that's all we're going to talk about with direct variation, but it is expected that you guys will be able to identify whether an equation or graph, as we saw on the last page, show direct variation. Oh, you'll also have to be able to do it from a table. Okay, so now we're to standard form. As we've talked about just a couple times, standard form is when you have an equation where x and y are both found on the same side of the equation. And when we graph in standard form, we could always make a table, but we have found that graphing with slope-intercept form is a lot easier. We could also find the x and y intercept, plot our 2 points, and connect. But I think what I'm going to do here is I'm just going to solve for y. So I'm going to subtract 8x from both sides. Sorry, this is hard for me to write. I'm using my mouse to do this. So now I'm going to come down here, negative 5y equals, and I'm going to write it with the x first just because that's how I'm used to seeing slope, minus 15. And then I've got to divide by negative 5 so that the y is by itself. So the equation I'm left with is y equals 8/5 y, and we're okay with the fraction because that's our slope, and slopes are okay with fractions. And luckily for us, this turned into a whole number. So as we've learned before, I'm going to plot my y-intercept. So I'm going to come up here to 3, and then my slope is going to let me know how to graph. Now, this is a positive 8, so normally I would want to count up 8, but I don't have enough room here. But I have learned that 2 positives are the same thing as 2 negatives because they will cancel. So I can actually go down 8, 1, 2, 3, 4, 5, 6, 7, 8, and back 1, 2, 3, 4, 5. So they started out as being positive. So if I want to make it continue to be positive, I have to go down and to the left. Now I really should have 2 points here, so I can kind of estimate 1, 2, 3, 4, 5, 6, 7, 8. It would probably be somewhere around here. That may not be perfect. But we connect our points to make a line. I do not have any domain and range here to restrict my graph, so I'm going to go ahead and put arrows on there. Now, if that made total sense to you and you're ready to move on, then stop the video and move on. If you'd like to see another example, then here's another example. So again, I want to get y by itself because I want this in function format with y as the output and x as the input. So I'm going to subtract 9x from both sides. So I'm one step closer because now the y is closer to being alone, and I have negative 9x plus 10. You guys don't have to put the x first. That's just how I'm used to seeing slope-intercept form, so it's how I like to do it. Now I'm going to go ahead and divide everything by 2. And I get y equals negative 9/2. Don't change this to a mixed number. Don't change it to a decimal. We like fractions when dealing with slope. And we've got a positive whole number for our intercept. So I'm going to start with my y-intercept of 5. I'm going to go down 9, so I end up here at negative 4, and to the right 2. Now, doing another point here won't really work because my graph is so small, so I'm just going to go ahead and connect my points. That is the worst line ever. You guys are going to do a much better job by using a straight edge. And there we have graphed in standard form. So graphing in standard form just means rewriting the equation to get slope-intercept form. That's all I have for you guys with notes today. Make sure you guys are getting your homework done and helping each other out if you need it.